A few of you have asked me for a basic explanation of what problem we're trying to solve with BioBricks and what BioBricks is. So let's jump into it. With everything we're building, we're trying to make informatics move faster. With BioBricks, we make informatics move faster by giving people a really easy way to use data as a dependency, or to go out and get data and start using it with their internal data science projects. So BioBricks is a data registry, but before we talk about exactly what that means, let's talk about the problem a little bit more. Anaconda, a package manager for Python, releases the results of a State of the Data Science survey 2020. They asked data scientists, where do you spend most of your time? And the scientists came back and said, well, we spend about half of our time loading data, so writing scripts to go out and find data and load data. And then, about a quarter of our time is spent just cleaning that data so it works with our internal system. That's a lot of time. So about half their time is spent loading and cleaning data. If you're paying a data scientist to work with you, you might not be thrilled to learn that half their time is spent loading data and cleaning data, especially if that data, already exists somewhere as a public database, something like that. What's worse is that this process is highly redundant. So if someone writes a script for going on and getting data and cleaning it, it'll probably be very similar to a script somebody else writes to do the same thing. And there are literally thousands of data scientists, maybe tens of thousands, who are sort of doing the same thing over and over and over again. And perhaps the same person ends up writing the same script for the same resource, multiple times. I can't tell you how many times I've written scripts for getting data from PubMed, for example. So this is a big problem. And the thing is, it could be a lot easier. The fact that it's so hard is one of the reasons that most informatics tools today really depend on a single database. And that's just because, identifying all the databases that are relevant, that's difficult. There's a big piece of this puzzle that's not even mentioned here, which is how do you discover the right data? But if you're going to use multiple databases, then you need to maintain a data pipeline. You need to maintain code for getting data from each resource. And you need to maintain the harmonization of those resources. So it gets more and more difficult to do that as you add more resources. So there's a problem with discovering data, a problem with harmonizing that data, and BioBricks creates a system around data dependencies. It relies on Git and it relies on DVC. I'm not going to talk about those technologies too much today, but please take a look at the other videos for learning more about the technicals about how BioBricks works. And this project was funded by the NSF in SBIR 2012-214. So before we get into the live demonstration, I just want to underline the problem just a little bit more. So if you're an informatics researcher and someone is working with you and maybe working on some new problem, they might ask you to go out and find the data to address that problem. Identifiers.org is a registry of many of these health informatics databases. It lists about 800 of them. There's some redundancy in that number. So, all the assets are a little bit different, but some of them are sort of the same parent resource. You can see multiple animal, genome, cattle references here. But still, there are hundreds of health informatics databases, bioinformatics databases on identifiers.org. And, if someone were working with, let's say, allergies, you might come on here and find allergome, and you'd read the description, and you'd see that it's about IgE binding compounds, and that might be talking about well, you don't really need to know the details. You just would know, maybe I should look at this database. And so you'd go ahead and pull the URL, and you could see there's information about allergens here. And you could dig into a lot of stuff on this website. You might find some publications. But what's not immediately clear is how do you get the data? And this is a very frustrating thing for an informatics developer because we have tools that are really good at manipulating tabular data. And we work with those tools every day. And almost all databases, almost all of those 800 databases distribute tabular data. So why isn't there just like an easy way to get the data? And that's the problem that BioBricks is trying to solve. Let's make it so every one of these data assets and more have a simple install data asset line we can run so we can start working with the data. So BioBricks does that today. And let's say we were interested in working with it. All we'd have to do is run pip install BioBricks, and this machine already has it, but that's, it would run and you'd have BioBricks. So you have BioBricks now. And let's say you were interested in working with gene names. So you might install HGNC, which is a database that has information about gene names. And so this is just going to go out and get HGNC and pull the table from HGNC. And now we have HGNC. So if we wanted to work with it, we could work with it in R, using tidyverse, a set of packages for manipulating tables, and the BioBricks package. And the BioBricks package is actually super lightweight. All it does is tell your system where to get the tabular data that you've installed. So in this case, we pulled HGNC, and we could run bbload HGNC. And now we've loaded HGNC. And you can see that it has just one asset, and it's this table, and these are the column names of that table. Now, if we want to look at that table, we're going to keep this video simple, but you could just take that asset, and then you could take the head of that asset, and you could collect it, and that's going to display it for us. And we could make the width a little bit wider, maybe. Yeah, there you go. So you've got gene names, locus groups, a bunch of other information related to genes. And the point is that we pulled that database and we can start analyzing it immediately. There's no like learning a new system, learning an API, or anything like that. And if we were trying to do that, online, well, we could search for HGNC, take us to genenames.org. We could see that there's, gene data reports, there's tools, and if you're not familiar with this space, like, this is going to be a big time sink, right? And you might start saying to yourself, well, I know there are tables behind this thing. Why can't I just have all the tables? We can talk about why these systems came to be, but the truth is that most of these health informatics resources, are relatively small data, multiple terabytes at most. So it's really not that hard to just pull the whole resource and start working with it. And that's what BioBricks lets you do, which has the side effect of dramatically accelerating development using any of these data assets. So let's just show how that would work in Python. Python and R are two really popular languages to work with tabular data, but the BioBricks system is just storing data in Parquet files locally. So basically, it's just storing data in a way that you can work with in any language. So Python and R are just examples here. We could just import BioBricks and Pandas, a common package in Python for manipulating tabular data. And if we were interested in Tox21, we could go ahead and install Tox21. That's just going to take a moment. Now we have Tox21. And if we wanted to work with it in Pandas, we could just go ahead and import BioBricks and Pandas. So T21 is equal to BioBricks.load Tox21. And you can see in this case, Tox21, you can use tab completion to see that it has 3 tables. And every brick that's distributed with BioBricks is an open source project, Git project. So we can go to github.com/BioBricks.ai. We want to know, where this data is coming from. Well, it comes from Tox21. That's the original source, but somebody's written some scripts for, reducing that resource to 3 tables in this case. And we can look at how they did that by going to the repository that supports this brick. And if we had a problem with how they did it, we could file an issue on GitHub, or we could pull this brick and work on it ourselves and create a new Tox21 brick, which is sort of the beauty of the open source data distribution system that is BioBricks. So if we know this resource and want to start working with it, or just want to just discover what's going on here, all we'd have to do is run T21. We're going to look at the first table there, and we're going to go ahead and load it. Sorry. We're going to go ahead and read it and just map it to pandas. And we'll say up that to a data frame. And now BioBricks is out of the way. So we can see, immediately we can start manipulating this table. And these data assets fit in memory, but BioBricks distributes data in a way so that you can work with these data assets even when they're too large to fit in memory. I'll refer you to the other videos on this channel to learn about that. So what problem are we trying to solve? We're trying to make health informatics data easier to access and make it easier to distribute your own data assets so that people can build new data assets in the health informatics space faster. So faster health informatics. That's the problem. Thanks for watching to the end. If you're interested in this problem, please like and subscribe and check out the other videos. Thank you.